In this video, we're going to go through and look at how do I transform any function whatsoever, as opposed to transforming certain functions like we did with quadratics or anything else in Algebra 2. So the first thing I'm going to do is look at a general form. I'm going to fill this in and then talk about how these transformations affect any graph. So if I have a number outside of my function, then I'm going to have a vertical shift. Vertical meaning up, down. So it's just going to move my graph up and down, whatever the value is that's outside, typically at the end of my function. On the inside, this C value here, anything inside in terms of plus or minus is going to move me left or right, so we're going to call that a horizontal shift. And the thing to remember about horizontal shifts is we always take the opposite of the number inside. So if it's a -2, then it's going to be right 2. We're taking the opposite of the horizontal shifts. Working our way across, we get to the B value. Now we're not going to deal with B if it's anything except 1 or -1. We're not going to look at any other number, which gives you some sort of stretch in your function. So I'm going to say if B is negative, then we're going to have a reflection over the y-axis. A reflection over the y-axis, which means if I have a point, say, there in quadrant 1, a reflection over the y-axis would put it over there. So we're reflecting it across that axis. And again, that's if B is negative, and for us that's just going to be -1. The f out here just gives us the shape of the function, which will mean a lot more once we start replacing f with certain parent graphs that we have. For now, we're just going to leave it as f or some other letter. And we have a. A does two things. I'm going to say if a is negative, we're also going to have a reflection, but that reflection is going to be over the x-axis. So we're going to flip it upside down, which is the typical way that we flip functions. So if I have a function up there, it's going to flip upside down. He's going to end up down there. So it's going to change the y value, flipping it over the x-axis. And here I should have labeled flipping it over the y-axis. So we have a reflection, it's just a different reflection. And lastly, I'm going to say if a is greater than 1, we'll have a vertical stretch. In other words, my graph is going to grow in its height. And if 0 is less than a is less than 1, in other words, if a is between 0 and 1, some sort of fraction in there, we're going to have a vertical shrink. In other words, it's going to get shorter and usually a little bit fatter. And now notice I'm talking about a values here. I break it into two different sections. So for example, if my a was -1/2, I would see this as reflection coming from up here, and then I'd see it as a vertical shrink coming from down, I should say down there. So I don't really look at it in terms of the negative being a negative value. The negative just means reflection, and then we look at the a value. So there's all the transformations that I can do to any function. A couple things to notice, fun facts. Notice how everything here outside is talking about vertical. So any number outside the grouping symbols is going to affect the y value, because it's changing how we go up and down. Any number inside of the grouping symbols is going to affect the x value. Notice how he was horizontal, moves it, or here it changed the x values going left and right with the reflection. And lastly, we're going to follow the order of operations, or order of operations in the applying. So notice how we have a times something and then plus, so a multiplication, then addition. So we'll do the multiplication first. So a will be done before d. So if we look down here at some pretty straightforward examples of what we're talking about here, I look at some transformations, and I just want to say how have these been transformed. So if I look at my first function, I'm going to start with the outside here. That is a vertical shift up 4, because he's outside, it moves me up or down. You can say vertical shift, or you can just tell me this graph has been moved up 4. We know that inside moves me left or right, but it's opposite. So I'm going to say this looks like it would be left 5, but since I'm doing opposite, he's going right 5. So I take whatever my initial graph was, or my initial function, I move the whole thing right 5 and up 4. For B, inside here, I can see that this is going to be left 2 because it's opposite. And then this negative out here gives me a reflection. That's what negatives do. So I have a reflection, and since it's outside, it's going to be over the x-axis. In other words, I'm flipping this graph upside down, not left-right. And then lastly, part C, that 5 means I'm moving up 5. That negative, again, gives me a reflection. But this time it's a reflection over the y-axis. So in other words, I'm flipping my graph left-right instead of up-down. And lastly, here I have a vertical stretch. It's a stretch of 3. This graph is going to go 3 times as high as the other graph. The total height is going to be stretched by a factor of 3. So we just take those places and we go through and look at what numbers are there and how do they affect my initial graph. Speaking of graphs, if I have the graph of f of x right here, this guy right here is my starting point. So I'm going to start with that graph each time, and then I'm going to come over here, I'm going to look at those 4 and see which of my graphs matches the transformations that have happened. So if I look at the first one, I've been moved right 2 and up 4. So if I imagine this guy here, right 2 and up 4, he should kind of look like that, which is exactly what I have right there. Right 2, up 4, and he hasn't been stretched or shrunk or flipped or anything. So my first one is B. For the second one, I've been moved left 2, down 4. So if I check out my options, left 2, down 4, and it hasn't been changed in terms of flipping it one direction or another, would give me C. This guy here, I've been moved, let's see, I've been reflected here, a negative inside, means I've been reflected up, down, so I should be upside down. And I've been moved up 3, and I have a stretch of 2. So I'm going to focus in on this idea of flipping upside down. So if that's my original graph, when I flip him upside down, he should have that sort of shape going on. Which if I look at all my shapes, this is the only one that has that sort of shape. Oh, if I do the right shape, flip it left, right, not upside down. What's wrong with me? Negative inside flips it left, right, sorry. So here's my original. Now let's flip him left, right. There's my shape. Now I'm doing this correctly. I apologize. So when I flip him left, right, he gets that different shape, and that is that guy right there. I almost had the wrong kind of reflection. So he's A. Now the 2 is a stretch. It's hard to tell what the stretch is on this graph because there are no y values anywhere on my graph. And lastly, we can tell this one's going to be D, but let's look at y. The negative out front is what flips him up, down, now that I have that correct instead of backwards. So he will actually go that direction like I tried to do before. So if I look at that guy right there, he is flipped upside down, and he will have a movement of an up 3 right there that matches with him. And the negative 1/2 as a stretch is kind of hard to tell because we don't have any y points labeled. So that'll be D. So I can match up these graphs just by looking at the different transformations and seeing how they affect my graph. He was up, down. There we go. In the next video we're going to look at is how do we go through and actually graph a transformation. If we start with something like f of x right there, how do I produce one of those 4?